Good afternoon, everyone. Welcome to eighth week of discussion session of the course Plates and Self. Uh, the course instructor of this course is Professor Sudik Talukdar, and I am your teaching assistant. Myself, Asif Raza. I am a PhD scholar from Department of Civil Engineering, ISC Bangalore. So today we'll be discussing questions relevant to assignment 6. So let's start. Yeah. So the first question is: the governing differential equation of a plate subjected to uniformly distributed load Q and uniform tension P acting along x equal to 0 and x equal to a normal to the edges is given by. So in this problem we are given with a rectangular plate and the load is uniform tension P is on this and there is a uniformly distributed load Q over the plate. Say this is x equal to 0, this is x equal to a. So what would be the governing differential equation? So we know with the application in plane loads, the lateral loads produced by it is given by nx del square w del x square plus 2 nxy del square w del x del y plus ny del square w del y square. So as a result, the plate equation changes t to the power 4, okay, so d to the power 4 w and its cube plus p star. In the given problem, nx, okay, in the given problem p star is equal to p L square w del x square. So the plate equation now changes to q plus p del square w del x square, that p to the power 4 w minus q minus p del square w del x square equal to 0. So this is my plate equation. So correct answer would be D, because if I take this and divide by d and all by the old divide by d to all terms, will get the equation D. Okay, let's move on to the next question. There is a thin plate of size a by b acted upon by inclined forces nx and y and xy equal to nyx. The self weight of the plate is neglected. Area stress function is given by this, where a, b, c are non-zero constant represents. So the option we have all are relevant to and asking about nxy. We know nxy is given by the relation tau xy times h, and tau xy is given by minus del square f del x del y, which is equal to minus del square of ax square plus bxy plus cy square upon del x del y. So this will give me tau xy is equal to minus b, yeah, so this will give me nxy is equal to minus bh. So if we see all the options, we'll get option B as my correct answer, as B is a constant value. So here we have. Let's find all the other stress values also, like nx will have as sigma x times h, and ny will have as sigma y times h. Sigma x is given by del square phi by del y square. So this will be equal to, if I take with respect to y, this will be 2c. So this will give me nx as 2ch. Sigma y is del square phi by del x square. So sigma y would be equal to 2a, and ny would be equal to 2a. So if we see all the values, we find that this in plane forces are all constant values. Okay, now let's move on to the next question. A rectangular plate simply supported along all edges is subjected to compression in the direction of length. The number of halfways in the width direction required for buckling of the plate is, so as we have all seen in the lecture, so the correct answer would be option A, 1. Okay, so let's move on to the next question. Okay, so in a rectangular plate A by B as shown in figure above is subjected to in-plane force Nx, which varies linearly on the vertical edge. The value of k in area stress function for such problem would be, so we are given with the area stress function as this. So what would be the value of k here? So okay, so we know nx is equal to sigma x times h, correct? And sigma x is equal to del square phi upon del y square, and sigma x is del square c y k minus 1 del y square. So this will give me sigma x as c times k minus 1, and again k minus 2 by k minus 3. So finally nx would be equal to c times h k minus 1 k minus 2 and by k minus 3. According to the question, it varies linearly on the vertical edge. So as you see, there is a dependence with this equation. We see there is a dependence of y as in power k minus 3. So k minus 3 would be equal to 1. That will give me k equal to 4. So finally my nx would be equal to what? 4 minus 1, 3, 2 is 6, 6, C, H, Y. Correct answer would be option D. Now next question. A long rectangular plate of dimension A by B, a long rectangular plate, is simply supported at x equal to 0, x equal to A and y equal to 0, but the plate is free at y equal to B. The critical stress factor K for such plate can be approximated as. So if you see just module 6 and lecture 3, you have the value for a long rectangular plate, critical stress factor value as 0.456 plus p square upon a square. So next question. A plate 1 by 1 and thickness 10 mm is subjected to uniformly distributed load Q equal to 1000 Newton per mm square. Newton per meter square. All edges of the plate are simply supported if uniform tension N equal to 100 Newton per meter is applied along two opposite edges, taking only first term of the Navier series, the central deflection correct up to 3 decimal places is. So okay, so let's write what we have first. We have a square plate. It's A equal to B equal to 1 meter. You can write is 1000 mm. Thickness of the plate is 10 mm. So these are the given things. Q is equal to 1000 Newton per meter square. So it will be 1 into 10 to minus 3 Newton per mm square, and this tension N is applied along two opposite edges. So I can write it as Nx is 100 Newton per meter. So this would be equal to 10 to the power minus 1 Newton per mm. Okay. So with this I can find the fractional stiffness of the plate. I have given with E. Okay, no, not required. Okay, so we are missing with the values. Young's modulus value will take as 2.1 into 10 power 5 Newton per mm square, and mu is equal to, I said to take a value of 0.3. So with this we'll get the flexible stiffness of the plate as cube 12 1 minus mu square. So 2.1 into 10 power 5 10 to the power cube 12 1 minus 0.3 square. So this would be equal to 2.1. Okay. Three. So this would be equal to 1.923 into 10 power 7 Newton. Now, as we seen in the first, as we saw in the first question, we had the plate governing plate equation for this type of question as this. So we'll use this one only. So we have the plate equation as del to the power 4 blue plus equal to q by d plus p by d, where okay, so can simplify p by d, where p is equal to nx del square w by del x square. Now in the question there is the thing that we can take the first term of the Navier series. So assume w of x comma y as. So normally in Navier series what do we take as a m n sine m phi x by a sine n phi y by b. But using the condition m equal to n equal to 1 and a equal to b, we get w of x equal to a11 sine pi x by a sine pi y by a. Okay, so del square w by del y square would be equal to sorry, x square. So that would be equal to pi by a whole square. This will minus a11 sin pi x by a pi y by a. Similarly, del power for del y square would be equal to now del power for w del x power 4 is equal to, this would be equal to pi by a to the power 4 a11 sin pi x by a sin pi y by a to the power 4 del y to the power 4 and del power 4 del x square del y square is equal to, this is also equal to the same thing, sin pi x by a sin pi y by a. So using all this thing in this plate equation, so we have del power for w is equal to q by d plus nx is equal to 10 power minus 1 . Okay, let me write first as nx by d plus by w by del x square. Del power for w is del power for w del x square plus 2 del power for w del x square del y square plus del power for w del y to the power 4. So this will be equal to, so 2 plus 2 plus 2 4 times pi by a to the power 4 a11 sin pi x by a sin pi y by a. Substitute this in the equation there. We'll get 4 pi a4 a11 sin pi x by a sin pi y by a. Q is equal to 10 to minus 3 by d is, okay, just write d as of now, plus nx is 10 to minus 1 d. This is del square w by del x square. This would be equal to minus pi by a. Let me write it more properly. So substituting those equations, we'll get 4 times pi to the power a 4 a11 sin pi x by a and pi y by a, which is equal to q by d plus nx by d del square w by del x square, that is equal to minus pi by a whole square a11 sin pi x by a sin pi y. On simplification, we'll get now multiplying both sides by sin pi x by a sin pi y by a, we get as 4 divided by a to the power 4 plus pi by a whole square plus by d and square is okay 28. Okay, q by d sin by x by a sin pi by a dx dy. So this will be equal to pi by a square x by d. This will become this, and sin square pi x by a will be equal to let's see, sin square pi x by a 0 to a 1 minus cos square. So we have from 0 to a sin square pi x by a dx is equal to a by 2. Similarly, from 0 to a sin square pi y by a dy is equal to a by 2. So this would be equal to a square by 4, and we have q is equal, take q naught by t, and sin pi x is okay, so can take 0 sin pi x by a dx is equal to minus cos pi x by a pi by a 0 to a. So cos pi minus 1 minus 1 pi by a. So this is equal to 2a by pi. So 2a by pi, 2a by pi. This will give me a11 as a square cancel out 4 times, so this will be equal to 16. q naught by d. Okay, I can take q naught by d, pi square d, and this term pi by a to the power 4 plus pi by a whole square nx by d. Substituting the values of q naught and d and a will get a11 value as 0.216 mm, and we need to find the central deflection. So for central deflection we will substitute x equal to a by 2 and y equal to a by 2, and we'll get a11 sine phi a by 2a, and similarly pi a by 2a, which is equal to a11, which will give me 0.216 mm. So this is my answer. Okay, now let's move on ahead with the 7th question. There is a rectangular plate simply supported on all sides, is compressed in x direction. The x-axis is along the length of the plate. Given a equal to 900 mm, b equal to 600, taking thickness of the plate as 10, Young's modulus as 2 × 10⁵ Newton per mm square, Poisson's ratio is 0.25, critical ratio for the plate in Newton per mm square nearest to first decimal place is. So we are given with a 900 mm, b 600 mm, thickness of the plate as 10 mm, Young's modulus as 2 × 10⁵ Newton per mm square, Poisson's ratio as 0.25. With this we get the flexural stiffness of the plate as minus nu square 2 × 10⁵ 10 cube 12 1 minus 0.25 whole square. So this would be equal to 2 × 10⁸ divided by 12, 1 minus 4. So this is equal to 1.78 × 10⁷ Newton mm. Okay, now we have the ratio of a by b value as 900 by 600, which is equal to 3 to 9, 3 to 6, which is equal to 1.5. And since this 1.5 a by b value lies between root 2 and root 6, so m value is equal to plus m equal to 2. M equal to 2, so the critical stress factor K would be equal to mb by a plus a by mb whole square, which is equal to 2b by a. By 3 by 4 equals to so this is equal to which is 12 whole square. This is equal to almost 2.17, 4.34 this, and we have critical stress value we get as K d pi square by b square. So we have 4.34 d as 1.78 into 10 power 7 pi square divided by 600 square. So this will be 4.34 1.78 into this will be equal to 211.907 Newton per mm. So our critical stress would be equal to NCR by H, that will be equal to 2117.907 divided by H is my 10 mm, so 211.7 Newton per mm square, and I have to round it to first decimal place, so this would be equal to 211.8 Newton per mm square. Okay, now next question, last question for today's session. There is a rectangular plate simply supported along edges is to carry an in-plane compression of 1080 kilonewton per meter at short range. The plate is simply supported along all edges. A equal to 900 mm, B equal to 300 mm. Young's modulus is 10.5 Newton per mm square and Poisson's ratio is 0.3. We need to find the thickness of the plate to nearest exact. So A is equal to 900 mm, B is equal to 300 mm, E is equal to 2 into 10 power 5 Newton per mm square. Young's modulus is 0.3. Thickness we need to find. Okay, in-plane compression, so that is Nx is equal to 1080 kilonewton per meter. So this is equal to 1080 Newton per mm. Okay. Now so let's find the ratio of A by B. A by B is 900 by 300, which is equal to 3, right? And as we get 3, as you see 3 is a whole number, so 3 is a whole number, so let's equate the critical in-plane compression sorry. So let's equate the, so let's equate the in-plane compression with the buckling load. The minimum thickness plane which is be equal to NCR is equal to K D pi square by A square, sorry, pi square by B square. and for this we'll have k value equal to 4. So, we'll just substitute 1080 equal to 4 times d times pi square by 300 square. Implies that d would be equal to 1080 300 square 4 pi square, and we have d equal to EHQ by 12 1 minus mu square. This will give me EHQ by 12 1 minus mu square is equal to 1080 300 square 4 pi square, and E value is 10 power 5. We need to find the H value. 12 1 minus 0.25 or 0.3. 1080 300 square 4 pi square. So this will HQ equal to, so that's fine, 1080 times 300 divided by 4 divided by pi square times 12 divided by 2 times 1 minus. This is equal to 134.4392. So simplifying, we'll get H value as 5.122 mm. So rounding off to nearest integer, minimum thickness should be greater than this 5.122. So H minimum would be equal to 6 mm. So this would be my answer. Okay. So this is my answer. This gives my answer. So if you guys have any doubt anywhere, you can post it in the discussion section. That's all for today. I suppose you guys won't have any more doubt. Okay, thank you all. Have a nice day.